When I was a kid, I had one of these. I lost it, and then I bought this one on eBay for an embarrassing sum of money. It's a He-Man AM radio. I don't think I used it for that though. I don't remember being interested in talk radio. But what I do remember is my dad and I modifying it to work as a door alarm for my room. Here's a reenactment of how I remember that working. By the way, this video is about me making an audio amplifier for the speaker inside He-Man. And for fun, I want to use only discrete components. No ICs. Okay, back to the reenactment. I only have a few goals for my circuit design. I want to be able to cleanly drive an 8-ohm speaker from an audio source such as a phone or computer jack for now, but in the future I intend the source to be from a demodulated RF signal. I don't know much about audio, so I don't know how much power corresponds to how loud something is. I'm sure not all the power I dump into the speaker is converted into sound waves. That's kind of a parallel from what I know about antennas. Given that the load is 8 ohms and I'm gonna drive this from a 9-volt battery, I don't know, I'll shoot for maybe a half a watt or a watt. I also want a mechanism for controlling volume, so I'll try to use the potentiometer that comes with He-Man. I'll make it so that it can receive audio from an external source like a computer for now, but what I really want to do is find maybe a design or two I can use for future radio projects. I haven't done much with audio, so this is kind of an exploratory project for me. To see what I'm working with, I'd like to know what voltage is coming out of my phone or computer. This auxiliary probe is connected to my computer, and I'm measuring the output signal on my oscilloscope up here. I see that the signal seems to kind of jump around up between a little over 2 volts peak to peak. I can make this a little bit clearer by turning on persistence. And yeah, a little under 2.8 volts, or about a 1.4 volts magnitude. Here's the problem for why I need an amplifier. If I were to hook my phone or computer directly to the speaker, it would look something like this, to first order approximation minus parasitic inductive loading. This is the computer on the left, and this is He-Man. The computer will have a source resistance in series with the voltage that's used to drive He-Man, and He-Man's just a load, just a resistor. The power going into He-Man is just going to be the voltage here squared divided by He-Man's resistance, which I looked, and on the speaker it says it's 8 ohms. From the voltage of the computer, V out is equal to this voltage divider, and thus the power that goes into He-Man based on this voltage is, let's say I have a peak voltage of 1.4 volts like we saw on the oscilloscope. We know RL is equal to 8 ohms. From Wikipedia, I saw that RS can be somewhere between 100 ohms and 600 ohms. So using this formula, we get power into He-Man equal. So the highest this power is going to be is somewhere around 1.3 milliwatts. That's peak power. If I had a sine wave going in, it'd be about half of this. And if 600 ohms was in there instead of 100, then this would only be smaller. I imagine 1.3 milliwatts is going to be pretty quiet. What I'd really like to do is remove RS somehow, make it 0. Then, suppose this was 0, then I would get something more closer to 1/4 of a watt. So just by removing this source resistance, or lowering that source resistance, I can get quite a bit of power gain. And if I further was able to somehow increase the voltage, I could get the power even higher. So that's what I want to do. I'm going to build an amplifier, and I'm going to reduce this source resistance and increase that voltage. And what I've talked about so far, this has just been peak power. Say I put in a sine wave for the voltage and I want to know what the average power is. That just works out to, in this case, half of that. Just as an experiment, which may short out the audio output from my computer. What happens if I connect my computer's audio output directly to the speaker? It's a little quiet. Looking at the oscilloscope now, I see that the peak voltage only gets in and around maybe 170 millivolts. That's this voltage right here. So even though 1.4 volts peak is coming in from the computer, the speaker's 8 ohms is loading down that source so that the voltage here is now only 170 millivolts peak. With 170 millivolts peak voltage going into that load, I know that my peak power is approximately 3 milliwatts. On average, let's say it was a sine wave, then it would be more like 1.5 milliwatts. Maybe you feel a little bad about pulling the guts out of this radio. I mean, look at it. Just a handful of discrete components and a couple of specialized parts. And this thing can demodulate RF signals out of the air. Magic. I'm going to keep 2 components from the original He-Man circuit. The one on the right is a cool dual-purpose part. It's a switch for turning He-Man on, and it's also a variable resistor for controlling He-Man's volume. The part on the left is a headphone jack. Originally it was used as an output for the headphones. I'm going to use it for an input from the computer or a phone. I really like these mechanical solutions for both turning the radio on and controlling the volume. You can see that as the wheel turns, the switches drop to connect the 2 outer leads. The 3 leads between my fingers are the leads to a potentiometer, which I'll use to control the volume. Okay, so here's the circuit I settled on. It's pretty simple, which I say after I've spent gobs of time in analysis and LT Spice. Before I do a little explaining, here is a circuit building montage. Damn it. Okay, so here's the circuit again. What I needed is an amplifier that has a high input impedance, a low output impedance, and a voltage gain of say 5-ish. I also wanted a large open loop gain so that when I apply feedback, I can improve the linearity of the amp. To make this look a little less complicated, this circuit can also be drawn something like this. This is where the computer/phone hooks in, and this is the output impedance of the computer. This is the He-Man potentiometer, which divides down the computer voltage to control the volume. I then go through this capacitor into the amplifier, where these two resistors bias something like an operational amplifier. I'm going to power He-Man from a 9-volt battery. So I set the voltage right here to around 6 volts, a point that when going through the real amplifier will make this around half 9 volts-ish. The amplifier has a high input impedance and low output impedance, and the effect of adding negative feedback further increases the input impedance and further lowers the output impedance. And this gives me exactly what I wanted. Basically, I can use these two resistors to set the voltage gain to this. And from the speaker's point of view, I don't see the output impedance of the computer, but rather the output impedance of the amplifier. This is that thing I was talking about earlier about removing the source resistance of the computer. Instead of pulling current directly from the computer, the speaker pulls current directly from the battery, controlled by these transistors. This is the actual circuit I'm using. It's only slightly more complex. In this section right here, I used a handful of transistors to implement this amplifier. These resistors right here are the feedback that produce the gain. You can look at it as this transistor producing a little bit of voltage gain, this transistor producing a lot of voltage gain, and these two transistors in a class AB configuration buffer the output so that the output resistance is low. Yeah, I think this will work. This current source is actually a couple of transistors that I use to control the bias current through this common emitter amplifier, which ends up making this an active load. And here's what this circuit looks like on the He-Man board. Okay, a test. Here's the circuit. The auxiliary cord is connected to my signal generator up there, which is outputting a 1-volt peak-to-peak signal. Instead of hooking the output to the speaker, I'm connecting the output to roughly 8 ohms. That way I don't have a speaker screeching at me while I look at the oscilloscope. This probe over here is connected to the input, so we should see the 1-volt peak-to-peak up on the oscilloscope up here, right there. And what I'll do is I'll turn the amplifier all the way up so we're not attenuating any of the signal. So for the reveal, bam. The divisions are set to 1 volt each. So a 1 volt peak to peak input gives you about a 5 volt peak to peak output, which is what I was shooting for. Since this signal is going into a 8 ohm load, I got about 5 volts. It turns out to be a few hundred, 300 to 400 milliwatts on average going into the speaker or into that resistor. What you'll notice is I do have a little bit of a problem here. If you look down here, it's not quite a sine wave. In fact, I'm going to go turn up the voltage just a little bit. Here I put in 1.4 volts peak to peak for the input, and you can see that I'm going to get a little bit of distortion right here. I could probably fix that a little bit by fixing some of my biasing, but I'm also running out of headroom with that 9-volt battery. I'm not sure I could do that much better with this design. I'm pretty happy with it. I guess the proof is in the pudding. Let's see how it sounds. Here's a demonstration of the effect that the low input impedance of the meter has on your measurements. I'm no audiophile, but that sounds exactly like what I'd expect out of a $10 80s toy. Despite its imperfections, it's loud and it doesn't sound too bad. I'm proud of this little project. I don't know how much use I'll get out of it, but I bet I'll use it more than I would have if I was still at AM radio. I'm happy I was able to design the circuit so that I could fit it within He-Man's head and get the switch/potentiometer to fit just right. And the thing looks exactly like it did when I had one when I was a kid. You'd have no idea that it's got new electronics in it. I did have to print a battery lid. This guy right here. I don't know if you can see that. I guess the eBay guy lost the old one. I think the circuit design might be a good one for future radio projects. Even if I don't use it, I learned a lot more about audio. Hey, if you made it this far in the video, thanks for hanging out with me.
Dinner's ready.
Okay.